erisangibwa Entebbe. Ssomero ly'abawala n'abalenzi lusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweweevu obulungi. Tulina ebisuula eby'omulembe, science laboratory ssaako ne computer lab wamu ne bw'osomeseza omwana wo mu masomero ga Giant Schools omuli kampasi y'e Bombo Kalule n'ey'e Kabalagala toba na bweraliikirivu bwonna olw'omusingi okutambuzibwa ebyenjigiriza n'ensoma y'abayizi ey'omulembe. Mu masomero gaffe gano gonna tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuuka ku siniya ey'omukaaga nga tusomesa abaana okuviira ddala ku mutendero gwa kindergarten okutuuka ku kibiina eky'omusanvu. Tulina abasomesa abakugu mu kubangula abaana n'okubateekateeka. Ebibiina abaana mwe basomera eby'omulembe omuli buli kimu ekikwata ku ebyo bye basoma, ebisuula ebyazimbibwa obulungi, ebigazi ate nga biyonjo. Okumanya ebisingawo tukubire ku nnamba z'essimu ez'owammanga.
Tubaniriza mwenna abalabi ba Terefayina musiibye mutyano bassebo ne bannyabo mwebala okutwagala n'okutwegattako mu puroguramu yaffe eya leero Ssomera Muddiiro lyo. Today it is in organic chemistry senior 6 and dear candidates, if you remember last time, I left you with a question. It was saying that you briefly describe how you can determine the percentage purity of an iron ore. Briefly describe how you can determine the percentage purity of an iron ore in the lab. Now, when they give you such a question, you use the theory which you have already gathered about iron, then you can describe an experiment. How do you do it? They have given you an iron ore. How do you determine the percentage of iron in that ore? Or how do you determine the percentage purity of the iron in that ore? And I thank those who tried. I really thank you very much. There are those who send me messages, the email messages. I hope I answer those questions to your satisfaction. Continue sending in the comments and the questions. I thank you very much. Now, for those who tried, if you tried really, I would expect to have written the following. It may not be exact. Most of you candidates, you want to reproduce exactly what the teacher said, but you can use your own words to mean the same thing. You can use your own words to mean the same thing. So, our question was briefly describe how you can determine the percentage purity of iron in a given ore. Now, determining the percentage purity, you should remember that this one now involves weighing, measuring. It involves weighing and measuring. Now, you would start by saying that you weigh the sample. In other words, you are using a given volume. So we can say that take a known mass of the iron ore. Take a known mass of the iron ore, so that you know I have used, like say, 2 grams or I have used 3 grams. Then dissolve that ore, dissolve the sample, the one you have measured, in dilute sulfuric acid. The question would be, why are you doing that one? Because if you have the ore when it is solid, there is no way you will know how much iron is there, if it is solid. But dissolving it in dilute sulfuric acid, the iron which is in the ore will form ions. It will turn into solution. It will turn into solutions. Now remember, you very well know now that ion can be ion 3, it can be ion 2. So we don't know in the ore which ion is there. Okay? It can be ion 2 or it can be ion 3. So when you dissolve that ore in dilute sulfuric acid, you will form ion 2 ions. That is if they were ion 2 ions. You will also form ion 3 ions if they were ion 3 ions. So we assume now that in our solution, if you have dissolved the ore in dilute sulfuric acid, either, you may have both ion 2 or ion 3. So the next step now would be to add zinc powder. What is the purpose of zinc? If you remember, if you have been following, we said, remember the other time we talked about things which can be used to reduce ion 3 to ion 2, and zinc powder is one of them. So we are saying after getting the solution, you add zinc powder. Add zinc powder. Add zinc powder followed by more dilute sulfuric acid. And warm. Why do you think we are adding zinc powder? We are adding zinc powder such that in case in the ore, in the solution, there are ion 3 ions, the zinc will reduce them to ion 2. Actually, adding this zinc powder, it is aimed at changing ion 3, which may be in the ore, to ion 2. Okay? Now, after adding zinc and dilute sulfuric acid and warming, we assume now the solution contains ion 2 ions. Even the original ion 3 have changed to ion 2. So from there, we can say you filter off the excess. Filter off excess zinc powder. Filter off the excess zinc powder. Then you remain with a clear solution of ion 2 ions. After you have filtered off the zinc powder, we have now a clear solution of ion 2 ions. Right? Now, what next? After filtering, now you have your filtrate, which is clear. Then we can say that you can dilute the filtrate to a given volume. Dilute the filtrate to 250 centimeters cubed. Dilute the filtrate to 200 centimeters cubed. This one we normally do in A level, we use a volumetric flask. Most of them are 250. So when you get your filtrate, a clear filtrate, then you add water until the volume becomes 250. Until the volume is 250. Now, after getting your solution, now 250 centimeters cubed, then you titrate. The next one now will be to titrate. You remember we said that whenever you want to estimate ion 2 ions, which reagents do you use? You should be knowing by now. Whenever you want to estimate ion 2 ions, you can use acidified potassium permanganate solution or acidified potassium dichromate solution. So here you can say titrate a given volume. A given volume of the filtrate or of the solution with standard. The word standard there is important. Standard there, it implies that you are using potassium permanganate whose concentration you know. Use standard potassium manganate. You use, acidified. It has to be acidified. Standard acidified potassium manganate 7 solution. Potassium manganate 7 solution. When we say a given volume, it means now you pipette. You can use a volume of 20 centimeters cubed or 25 centimeters cubed. Then you titrate that volume with standard acidified potassium manganate 7 solution. Now, then you calculate after this one. Now you will be knowing that this amount of potassium permanganate reacted with this amount of ion 2 ions. So after that one, then you calculate. Even last time I showed you how you calculate. Calculate the concentration. Calculate the concentration of ion 2. Why are we saying ion 2? Because the ion 3 which was there, assuming it was there, was already changed to ion 2 by using zinc. So calculate the concentration of ion 2 in grams per liter. Calculate the concentration of ion 2 in grams per liter. Now, after getting the concentration of ion 2 ions in grams per liter, then calculate the percentage purity of the ore. Yes, calculate the percentage purity of ore. Percentage purity of the ore, it implies that what percentage of iron is that in that ore. What is the percentage of iron? You may have an ore, but the iron which is there is very, very little. It's very little. So when we set the percentage purity of the iron ore, then you can get it by mass of iron 2 in the ore. You divide the mass of the ore, the one you weighed at the beginning, mass of, then you multiply by 100. If you use that expression, then you will get the percentage of iron in the ore. And of course, the percentage of iron in the ore is the one that will give you the percentage purity. It will give you the percentage purity of the ore. And you bag your full max. You bag your full max. That is what was expected. We expected you at least to talk like that. How you can calculate at the end, get the mass of the iron in the ore, then divide by the mass of the ore and multiply by 100. That one gives you the percentage purity. It gives you the percentage purity. Now, that was as far as the question was concerned. Now, the other time I told that we are going to a new topic, chromium and its compounds. We have finished chromium and its compounds. chromium and its compounds. We have completed now iron and its compounds. We are starting a new topic. Chromium and its compounds. The chemistry of chromium is very, very important. You should also be very keen because it also appears in practicals. They can give a sample for you to analyze which is a chromium, and you must be having the theory behind if you are going to be successful with those practicals. Now, chromium and its compounds, atomic number of chromium is 24. Electronic configuration, I hope you can, it is very easy. Now, if you atomic number is 24, then electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6. Those are how many? 4, 10, 18. 3s2, 3p6, then 3d5 and 4s1. I hope they are 24. 2, 4, 10, 12, 18, 23, 24. That is the electronic configuration of chromium. The electronic configuration of chromium. Then chromium is a bluish white shiny metal. It is a bluish white shiny metal. It is bluish white, a bluish white shiny metal, and it occurs naturally as chromite. It occurs naturally as chromite. It occurs naturally as chromite. If you are going to find the ore of chromium, or it occurs like in nature, that's how you find it, like this. Sometimes they write it like this, or you can put it there like this. It is the same. It occurs in nature like that. Now, extraction. You are not supposed to be going to the details of how it is extracted. It is a bit complicated. So we have to just talk about it in passing. Extraction, it is extracted by the Thermit process. By the Thermit process. By the Thermit process using aluminium. By the Thermit aluminium. And if you have the chromium plus they heat it with aluminium, then it gives you chromium plus that is the Thermit process using aluminium. The second one is by electrolysis. As I said, you will not be required to go into the details of what is the what. No. If they ask you, just say it is by Thermit process. Maybe if they want the equation, you write the equation. The second method of extraction is by electrolysis. The second one is by electrolysis. If you have a salt of chromium 3 ions in solution, then you carry out electrolysis, then the chromium ions, they will be discharged at the cathode. You will get chromium. This one is at cathode. You studied the electrolysis in O level, I hope. So at the cathode, the chromium ions will be discharged and you get chromium. You get chromium metal. The third one is by carbon reduction. Carbon reduction. However, this one mainly is when they want to make an alloy of chromium and iron, is when they use this one. This one is mainly for making an alloy of iron and chromium. That's when they use this method. That one is of carbon. That one of carbon reduction. Then you will get chromium plus, you get iron plus carbon monoxide. I hope. Is it balanced? So as I have said, this one is mainly for making an alloy of chromium and iron, is when they use this one. When you heat carbon and you heat carbon and chromium. Now, the next one is chemical properties of chromium, or we can say reactions of chromium. Chemical properties of chromium, or we can say reactions of chromium. Reactions of chromium. We are starting with the air. How does it react with air? With air, reactions of chromium. The first one with air. As you know, like most of the metals, at ordinary temperatures, they are not affected by air. At ordinary temperatures, you can look at zinc, be it copper, what, they are not affected by air at ordinary temperatures. But on heating, it reacts on heating to form By the way, when they ask you describe the reaction of chromium with air, don't forget this heating. It is the key thing. If you don't heat, it will not react. So it reacts on heating with air to form the green chromium 3 oxide. Form the green chromium 3 oxide. Then you write the equation, of course. Chromium plus oxygen then you get chromium 3, and this one is green. Then you balance. Balance the equation. I hope it balances like that. Yes, so like this. 6. I hope it balances like that. I have always told you that make sure you always check on the balancing. Eh? Make sure you always check on the balancing. Number 2, with water. With water. Also, chromium, it will not be affected by cold water. It cannot be affected by cold water. So, but if you heat with steam, it reacts still to form hydrogen gas and the chromium 3 oxide. If you heat with the chromium, we can say that it reacts with the steam on heating. It reacts with the steam on heating to form, just like most of the metals. When they react with water, it forms hydrogen gas, form hydrogen and chromium 3 oxide. And again, you write the equation, chromium plus. Now, don't put here L because this one is gas. We have said it reacts with the steam. So this one is gas. Then you get the chromium 3 plus hydrogen gas. Plus hydrogen gas. So that's how it reacts according to that equation. Hope you balance the equation. At least here 2, here 3, I think. Even there 3. Eh? You can always balance the equation. Number 3. With acids. With acids. With acids. Now, chromium reacts with dilute acids, the actual dilute hydrochloric acid and dilute sulfuric acid, slowly when they are cold, but more rapidly on warming. It reacts slowly. We can say it reacts slowly with dilute sulfuric acid or hydrochloric acid in the cold. But more rapidly on warming. More rapidly on, you have to get, it reacts in the cold slowly, but on warming it reacts rapidly. Okay? On warming it reacts rapidly with dilute sulfuric acid and dilute hydrochloric acid to form the blue solutions. Blue solution containing chromium 2 ions. Form the blue solutions containing chromium ions. The equation, you can write a general one. We can write the general one. You have chromium plus an acid then you will get chromium plus hydrogen gas. Forms hydrogen gas. That is chromium with dilute acids. It reacts and it forms the chromium 2 ions and hydrogen gas. Now, these salts of chromium 2, they turn to chromium 3 rapidly because of oxidation, because of aerial oxidation. So, the green solution turns the blue solutions turns to green. The blue solutions turns to green due to aerial oxidation. Due to aerial oxidation by air. Due to aerial oxidation by air. Aerial oxidation by air. These ones in the acid plus oxygen, then you get chromium plus water. The chromium 2 is oxidized. If we put here 4 and here 4, here 2, I think here it will also be 4. I think it balances like that. So the blue solution, I have already told you that the chromium 2 ions in solution are blue. They change to green. Chromium 3 ions are green. So when they react with the acids and they form the blue solutions, the blue solution will not remain for, after a very short time, it changes to the green. Reason is the chromium 2 ions are easily oxidized by air to chromium 3. That's why the blue solution changes to green solution. That is with the dilute acids. Now, with hot concentrated sulfuric acid, this one was with dilute. Now, with hot concentrated sulfuric acid, chromium 3 sulfate is formed. Remember, these ones were forming chromium 2 in this one. They were forming chromium 2. When they react with dilute acids, they form chromium 2. With concentrated sulfuric acid, they form chromium 3. You should get it now. With hot concentrated sulfuric acid, chromium 3 sulfate. Chromium 3 sulfate, sulfur dioxide, and water are formed. Sulfur dioxide and water are formed. Then you write the equation. Chromium plus sulfuric acid, chromium plus sulfuric acid, you will get chromium 3 sulfate plus sulfur dioxide gas plus water. Then you balance. Balance the equation. If here is 2, here 6, here it will be 3. Then here it will be 6, I hope. So don't say, why haven't I written these ones this side? Please, when you write the equation, whatever is the product should be on this side of the arrow. All the reactant should be on this side of this arrow. Products on that side. So don't bring this one this side. The equation will be wrong. Now, you have to distinguish. With dilute acids, you get chromium 2. With concentrated sulfuric acid, you get chromium 3. Okay? Now, there is nitric acid. You say that dilute nitric acid doesn't react. And concentrated nitric acid renders it passive. Concentrated nitric acid renders it passive. Now, we have dilute nitric acid does not attack chromium. It doesn't react with it. But concentrated nitric acid will make it passive. Will make it passive. So, I hope you remember in case they ask you the question which normally comes, describe the reaction of chromium with acids. They just say, describe the reactions of chromium with acids, and they stop there. So when you are describing, when you describe, you have to talk about the dilute acids, that is dilute hydrochloric acid and dilute sulfuric acid, then concentrated sulfuric acid, then you talk about nitric acid. Remember also to write the equations. Remember to write the equations. Most of these equations you can always remember if you were good in your chemistry in O level. Because as you can see, it is like metals react with acids, dilute acids to form hydrogen. Even chromium is forming hydrogen. Even chromium is forming hydrogen. Number 4, with nonmetals. With nonmetals, chromium combines directly on heating with directly with sulfur, nitrogen, halogens, and carbon. It reacts with all those ones. But remember, on heating, it doesn't just react with them if you don't heat. So it reacts with them on heating. And I hope the equations are not very difficult, at least for the nonmetals. If you can remember that it reacts with the sulfur, it reacts with nitrogen, it reacts with the halogens, and it reacts with the carbon. I don't think the equations would be very difficult. Chromium solid plus nitrogen. As long as you know your symbols very well, then it will form chromium nitride. If it forms chromium nitride, then you balance. It is chromium 3 nitride. with the sulfur, steel plus sulfur, then you get chromium sulfide. If you know the valencies very well, the valence of nitrogen is 3, this one is 3, so the formula is like that. If you know the valencies very well, with the halogens, steel, chromium plus chlorine, you get chromium 3 chloride. Then you balance the equation. Then with which other one? With carbon, steel plus carbon, it gives you chromium carbide. You balance. Please always make sure that you balance those equations. Don't write an equation which is not balancing, please. That is with non-metals. With non-metals. I think the important thing for you here is to remember it reacts with the sulfur, carbon, nitrogen, and halogens. Then the equation, if you know your valencies very well, because I cannot now teach here valencies. If you know your valencies very well, you cannot fail to write these equations. If your valencies are with you. Number 5, with the alkalis. Remember, when we talk about alkalis, we are implying potassium hydroxide and sodium hydroxide. Now, chromium reacts slowly. With hot, it reacts slowly. With hot, concentrated alkalis. Hot concentrated alkalis to form hydrogen gas. Form hydrogen and chromides. Or we can call it chromate 3s. Now, you see, if chromium reacts with the alkalis to form hydrogen gas, but we also said it reacts with the acids to form hydrogen gas. So it means chromium is amphoteric. Chromium is amphoteric. It can react with the acids, it can also react with alkalis. Remember, when it is reacting with the acids, it is behaving as if it is a base. When it is reacting with the alkalis, it is behaving as an acid. So, we can say chromium is amphoteric. Chromium is amphoteric. Then you write the equation for the reaction between chromium and concentrated alkalis. Chromium and concentrated alkalis. Then it will form plus hydrogen gas. Plus hydrogen gas. Then you balance. 2 here, I think, and here 2. That's how I hope it is balancing. No? Plus, there is also plus water. Sorry. chromium plus. And then you balance the equation. If we balance that one, and this one will be 2, 2. And this one 2. I hope it balances like that. Now, students find problems in, sometimes you find a student writes an equation very well, like this one. But then you find here, a student has put like this. When you put this one, it means it's wrong. This one is wrong. It means it is wrong. And if you see, if this one is chromium 3, this is sometimes how, in case you are confused a bit, if this one is plus 3, this one, oxygen, each oxygen is minus 2. And there are 2 oxygens. There are 2 oxygens. So the 2 oxygens will make the charge for the oxygen to be this. Now, if you combine this, you remain with the -1. And it is the one that you put here. It is the one that you put here, the balance. Because the chromium is plus 3, the 2 oxygens, both of them are -4. So when you combine, you get a balance of a negative. That negative is the one that you put there. The thing, it should not be disturbing you. It should stop disturbing you people. Because most people write and they fail it there. They fail it there, and the thing, of course. So you can write this equation, or you can write this. You can also write it like this. Now, before I put the charge there, on this one, still now you can tell, is it going to be a positive there? Is it going to be a negative there? If we are going to form, that compound, what is it going to be? So still, use the same technique. Chromium here is 3+. The OH, the hydroxide ion, is 1 negative. Is 1 negative, and they are 4. So that is 4 negatives. So the 4 negatives from the 4 OHs, and the 3 positives here, you will be left with a balance of 1 negative, which you put there. Which you put there. And then you balance. Here it is 6, here 2. I think. Like that, even here 2. I hope it balances like that. So the equation now, the choice is yours. You can decide to write this one or to write this one. I don't know. But don't write both. In the exam, don't write this one, then you put O, and again you write this one. If one of them is wrong, then you get everything wrong. So please, you decide which one is easier for you to write. You decide the one that is easier for you to write. But don't write both. And make sure they are balancing. Make sure that you balance those equations. So we have said chromium is amphoteric. This is how it reacts. This one is not balanced. This is how it reacts with the alkalis. Previously, we talked about how it reacts with the acids. And now we want to go to compounds of chromium. Compounds of chromium. Compounds of compounds of chromium. It forms very many compounds. Now, chromium exhibits +2 +3 and +6 oxidation states. In other words, the compounds of chromium, they can be chromium 2, can be chromium 3, can be chromium 6. So those are the oxidation states of chromium. Now, out of these ones, this oxidation state is the most stable. Of all those ones, the others are not. 3, the most stable, meaning that most of the compounds of chromium will be in chromium 3, because the +3 is the most stable of all these oxidation states, +2, +3, or +6. Now, after knowing those oxidation states, we want to briefly look at oxidation state +2. But that one we are going to just be passing very fast, because the +2 oxidation state is the least stable. And that one means the compounds in oxidation state +2 are also the least important. They are not very important, because every time you make the +2, it changes to +3. You make the +2, it changes to +3. That's why we are going to mention the +2 oxidation state very briefly. That is chromium in oxidation state +2. Chromium in +2 state. Chromium in +2 state. You can say this one is the least stable. This is the least stable, and therefore the least important. The least stable and the least important. Compounds of that state are not very important. And chromium 2 ions, solutions of chromium 2 are easily oxidized to chromium 3. Are easily oxidized to chromium 3. And I don't have to mention, I have already mentioned that aqueous solutions of chromium 2 ions are blue. Aqueous solutions of chromium 2 ions are blue. And the time is almost up. You can say that aqueous solutions of are blue. Aqueous solutions of chromium 2 are blue. And lastly, maybe we can say that if you want to get anhydrous chromium 2 chloride, anhydrous anhydrous chromium 2 chloride is prepared by heating chromium in a stream of dry hydrogen chloride. If you want to get chromium 2 chloride, don't say chromium plus chlorine, you will get chromium 3. So if you want chromium 2 chloride, then you pass the hydrogen chloride gas over heated chromium. You pass hydrogen chloride gas over heated chromium, then you will get the chromium 2. Can you guess what else you get? You chemists, can you guess what else you get? I told you metals, when they react, this one is an gas, a metal, then you get hydrogen and a salt. You balance like that. So if you want chromium 2 chloride, you heat chromium in a stream of dry hydrogen chloride gas. And I thank you very much for watching Babasa. I thank you very much for following the lesson and continue following the lessons. I thank those people who are making this lesson possible. I thank you very much. May the Lord bless you. Good.
Ssomera Muddiiro lyo ng'ewagiddwa Maryland High School erisangibwa Entebbe. Ssomero ly'abawala n'abalenzi.